In 2 minutes. Microphone включили, да? Okay, dear colleagues, we wait 2 minutes, and after 2 minutes, we will start our second day of our conference. And please, the paper number 205, please share your presentation. Thank you so much. Okay, dear colleagues, dear guests, dear participants, can we start the second day of our section number 3? And we are presented our articles, and please ID number 205. Can you share your presentation, please? Okay, thank you so much. And dear colleagues, please don't forget to turn on your video.
Okay, hello dear participants. Today by our program we will start with the paper ID number 205, but I think the authors of this paper are not here, so we can start with the ID paper number 230. Okay, so I think I see that one of author is here. Paper ID number 230. Yeah. Okay. Okay, please, can you turn on your camera, please? And your microphone too.
Dear participants, turn on your camera and your microphone, please.
Yes.
Okay.
Paper number, paper ID 230.
You can start. You have 7 minutes for your presentation. So please start.
Is my PPT available now?
It's available, but can you increase the size?
Yeah. Now is it clear?
Okay, thanks. So
Yeah,
7 minutes. Okay, you will be given 7 minutes, please.
Yeah, sure. So, good afternoon, everybody. I welcome you to my presentation on the topic that is enhancing AODV routing with machine learning for intelligent IoT path selection. Coming to the outline, in this presentation, initially it will be introduction, followed by the importance of energy efficiency, which is followed by literature review, then objective of the research, proposed model, as well as results and discussion, then conclusion. Well, coming to introduction, as we know, the IoT system consists of, basically refers to a network of devices that are embedded with sensors, softwares, as well as network connectivity. These devices are called as smart devices or smart objects. So these devices can communicate with each other with other internet-enabled devices to perform various tasks autonomously, like monitoring environmental condition or controlling process in factories or even tracking inventories in shipments. Whereas, unlike conventional internet-connected devices, these IoT devices often rely on limited battery power, which makes the energy efficiency a critical design concern. The core function of IoT being one is sensing, wireless communication, and data processing. Routing typically being the most energy extensive and complex engineering real-world problem. These issues degrade the overall performance as well as the reliability of the IoT system. Optimizing energy consumption is essential to extend the network lifetime and ensure stable operation. A considerable work has been done in this regard. To list a few, in the first article, the research presents a hybrid energy-aware protocol for data routing in IoT. It is based on machine learning and meta-heuristic heat optimizer. Whereas the integration of multiple complex algorithms may result in increased computational overhead. In the second article, the researcher presents a efficient optimal routing scheme devised with using artificial neural network. Here, the resource is allocated without prior information in relation with the network dynamics. Although optimized, frequent reconfiguration still introduces computational overhead and energy overhead. In the third research article, the author introduces a novel algorithm for RPL, that is a routing protocol for low power and low noise network, that is enhancing the RPL by incorporating random forest for advanced packet analysis and network traffic analysis. Here, the training data is very important. If the training data does not adequately represent the range of possible scenarios or network condition, the algorithm may lead to either false positive or negatives. In the third research article, the researcher employs an ant genetic hybrid optimization algorithm for multi-objective optimization. Further optimization is required for global optimum solution. This brings us to the problem statement. That is, the traditional routing protocols in wireless ad hoc networks or sensor networks, they basically rely on conventional mechanism to establish route dynamically based on current network topology. While it might be effective in some scenarios, this protocol often suffer from limitations such as high routing overhead, latency in route discovery, and reduced adaptability to frequent topology changes or node mobility. And moreover, these conventional routing decisions are typically made without taking in context the historical or contextual data, leading to suboptimal path selections and inefficient resource utilization. And this brings us to the objective of the research. That is, this research seeks to mitigate frequent route failures and transmission disruption in AODV by embedding a decision tree algorithm into the route selection process, enabling more informed and stable routing decision in ad hoc networks. Coming to the hybrid decision work that integrates decision.
Sorry, you have a problem with your sound. Sorry, we can't hear you.
Node, depending upon the source node, depending upon the transmission range, finds neighborhood which are within one hop destination length. If the destination node is present in this one hop length, then the route is then the data delivery will take place. If the destination node is not present within this one hop neighbor node list, then each of the neighbor node list will initiate a route discovery using the proposed AODV routing protocol. Meanwhile, the features as well as the labels to train the model are extracted and optimal route is discovered. This optimal route is stored in the route cache in the source node for to reduce further computational redundancies. Once the route is established, data is transmitted. Coming to results and discussion, the model is simulated with around close to 150 sensor nodes placed in an area of 150 cross 150 meters with a transmission range of around 50 meters. We can see the proposed AODV routing protocol has considerably less delay as compared to the conventional AODV across the iterations. Even when it comes to throughput, even as the iteration increases, the AODV DT has relatively high throughput when compared to AODV, even when as the number of iteration increases, the probability of reducing the battery energy below the threshold increases. Then coming to network lifetime. As we see, even as the number of iteration increases, the proposed AODV DT routing protocol maintains a considerably or I say relatively high routing protocol, high network lifetime compared to the conventional algorithm. When it comes to packet delivery ratio, the proposed AODV routing protocol fares well, close to 99.2% when compared to the conventional AODV, as well as enhanced AODV, again modified with machine learning protocol. And this brings us to the conclusion. This work presents an intelligent routing framework that integrates a decision tree-based machine learning model with the conventional AODV protocol to enhance routing efficiency in dynamic wireless networks. AODV outperforms standard AODV in energy efficiency, throughput, network lifetime, as well as when compared to packet delivery ratio, proving its effectiveness in dynamic IoT environments. Future enhancement should focus on real-world testing and hybrid machine learning heuristic models for scalable as well as adaptive routing protocol. These are the references. And with this, I end my presentation. Thank you.
Okay, thank you for your presentation, for your report. Any questions, dear colleagues? You can come here.
Thank you for your presentation. I have a question that you have mentioned about proposed model. Could you tell me about the data collection? Which type of the data collection you have collected and how many amounts?
Sir, your voice is not clear to me. Can you please repeat the question? I am not able to understand the question. Your voice is not clear to me.
Okay.
You have mentioned about your proposed model that you
Yes.
have a data collection. So which type of data collection you have collected? How many amounts? How you can use it?
No. For this, data has not been collected. We have simulated the model for different scenarios, and the parameters have been evaluated for to find out the efficiency.
How you can achieve the high accuracy of your proposed model?
By comparing with respect to the other existing models, even implementing those existing models, we have compared our modified model for the same input parameters.
Okay, thank you.
Okay, thank you so much.
Thank you.
Please, next paper number ID 239.
Of course.
So
Do you hear me?
Yes. The previous, okay. And kind reminder about 7 minutes time limit, okay?
Thank you very much. Good afternoon. My name is Igor Shapochka, and together with my colleagues, from Uzhgorod National University, Ukraine, I am pleased to present our work titled on computer modeling of quadratic surface intersection. The intersection of two surfaces is a fundamental operation in 3D modeling used in fields like geodesy, physics, engineering, and medicine. For example, when simulating satellite coverage over the Earth, the surface is modeled as a spheroid and the radial beam as a cone. The intersection curve defines the coverage area. This demonstrates both the practical and theoretical relevance of our study. Despite being studied for centuries, surface intersections remains a complex problem. Efficient algorithm often sacrifices accuracy or reality. Exact methods, also precise, are usually slow. Finding a good compromises between these goals, accuracy, reliability, and efficiency is a challenge we address. Particular cases of the intersections of the sphere and the cylinder can be found in the works of the 17th centuries. Among them is well-known work of Italian scholar Viviani, after whom was named the curve of intersection of a circular cylinder and a sphere, whose center lies on the surface of the cylinder and whose radius equals to diameter of the cylinder. Our goal is to develop parametric modeling methods for intersection quadratic surfaces using linear algebra and GeoGebra. We set out to analyze existing approaches, developed and implemented a new algorithm, visualize results, compare them to other methods. The idea of the proposed methods involves finding of a coordinate system in which the equation of one of the quadratic surfaces is simplified to a so-called simplest sum another canonical form. The surfaces for which the canonical coordinate system is determined will be referred to as control surface. The quotient of the intersections curve is found in the new coordinate system by solving, where possible, the system of second-order algebraic equation. If the control surface is degenerated, transitions to its common parameterizations allow solving the mentioned system of algebraic equations in the general case. Finally, using the inverse transformation of three-dimensional space, the equations of the intersections curve is obtained in the original coordinated system. This table lists common quadratic surfaces and their simplest forms which we introduced. Identifying the canonical form help simplify computations and classify the intersections behavior. The quadratic surface is called degenerate if its coefficients matrix is degenerate. This includes cases like intersections planes, double planes, and cones and cylinders. Recognizing degenerate cases is key to applying the methods effectively. Our implementation is built in GeoGebra via command line input. The steps include selecting the degenerate control surfaces, applying coordinate system transformation, solving the intersections parametrically, returning to the original coordinate system to get the final equation to the curve. We will illustrate the method with two surfaces, an elliptic cone and the hyperboloid on the sheet. One sheet, the intersection curve can be observed only due to the change of color gradient and the boundary of the intersection. We extract coefficients of the surfaces equation and form the transformation matrix to switch coordinate system. GeoGebra commands like axis help automate this step. We simplify the transformed surfaces equation using our classification table. Then we compute the intersection curve and convert it back into original coordinates. The result is visualized as shown in figure 2. We can show the curve of intersections of these surfaces, and intersection is computed and visualized in GeoGebra, demonstrating the effectiveness of the algorithm. Our methods builds upon the idea of Levens and others, including works on pencils of quadratics and geometrics intersection algorithm. However, many of these do not fully automate the process of phase limitation and exact computation. Compare to existing methods, our is more general with respect to coefficients, make uses of modern computer algorithm systems, tools like GeoGebra, handles degenerate surfaces, so current implementation is limited to cases where one surface is degenerate. And here is some references. We refer to seminal works of Levin, Miller, Goldman, DuPont, Lazarus, and others. Also recommended exploring the online computation server for surfaces intersection at Gamble, Florida, France. Thank you very much. I'm finished.
My name is Anita. I'm junior researcher, and my question is about implementation of this research. A really interesting topic. And for example, how do you think we can implement this research not only as in the school or university, but in the real science project? For example, currently in our center we have the project related with the water management. And do you think how maybe we can collaborate or implement your method in the to investigate the shape of river or something like that?
Thank you very much for the question. No, first of all, the first slide I have showed the one of the problem where we can these methods use. The other one, for example, in industries for something with such problem with English. Ну, есть станки, которые обрабатывают верстаты, так и дерево, например, можно цилиндрическими образцами каким-то образом обрабатывать, это должно бы помочь соответственно, для всякого такого моделирования.
Oh, okay, thank you. I understand more for industry, no for water management. Okay, thank you so much.
Thank you very much.
Next, thank you so much.
Next, 241, Adina Aykenova and Janar Oralbekova, yes?
Hello, everyone. I'm sorry.
So, Adina, please don't forget about strict requirements of the time limit, okay?
Okay, so my name is Adina Aykenova, and together with my co-author Janar Oralbekova, we have wrote a paper called Biometric Authentication Model based on palm veins. So the aim of our research is to develop a deep learning-based biometric model using palm vein recognition to overcome the limitation of traditional biometric systems. So our objectives are first to distinguish how can palm vein patterns be effectively used for biometric authentication. Then secondly, to recognize what levels of accuracy, false acceptance rate, false rejection rate can a convolutional neural network-based model achieve comparing to existing biometric models, and to identify can the model work well with different data sets and different conditions like lightning, occlusion, and so on for a real-world application. And while doing a research on past studies, we have come to a conclusion that fingerprints and iris recognition are the biometrics that are studied the most extensively nowadays, and but they have limitations in environments where precision is very important. So more recent studies on palm vein systems have highlighted that palm veins has unique security benefits, and they are because they are internal, they are almost impossible to replicate. And also, some studies recognize that the adoption of deep learning models for feature extraction and classification has shown significant improvement in biometric models nowadays. So we decided to combine palm vein recognition with deep learning techniques, specifically convolutional neural networks, in order to address limitations of existing biometric systems. And the features of our work is use of deep learning in palm vein biometrics, synthetic data augmentation via GANs, its improved performance over traditional biometrics, specifically focused region of interest extraction and advanced preprocessing techniques. And also, it has potential for real-world application and multimodal integration. In this slide, I wanted to show, introduce you the advantages and disadvantages of existing biometric systems, but generally saying they all have limitations. For example, fingerprints can be affected by dirt or cuts, and facial recognition may fail because of changes in facial features or lighting. And these issues highlight the need for a reliable, non-invasive solution. And I think this solution can be palm vein recognition because they are complex and internal, and it's almost impossible to replicate them. And they offer a perfect solution for environments with high level of security, like government, military, or banking. Talking about the datasets, I have used public dataset called Vera Palm Vein by Zenodo. It consists of infrared palm vein pictures, collected on they are collected under controlled conditions. And also, I have enhanced my dataset with synthetic data to improve robustness. Synthetic images were generated using generative adversarial networks (GANs) to add variations like lightning and occlusion. And in the resulting dataset, I have about 3,500 images that are split between real and synthetic data. This is the workflow of my system. As you can see, the palm image is the input. Then my system detects a region of interest. It preprocesses the image. It applies 2D wavelet transformation and local line binary pattern. And the last step is palm vein recognition. As a result, we have recognition result. It can be either accept or reject. And for preprocessing, we have used different filters in order to make our veins more recognizable by the system. So as you can see, in the original picture, it's just a palm. It's just the palm. Then we detect the region of interest and apply such filters like Clahe filter in order to highlight the veins itself, and by adding contrast. Then we use, for example, Gabor filter in order to highlight the structure of a vascular system on the palm. And like by combining and thresholding these filters, we can come to final result that is filtered veins. And this is what our system will compare in order to give a result. And as I said, we combined previously shown filters in masks. So this is the endpoint filtered paints after each mask application. So first, second, and the final one. This is the experimental setup and match model. So basically, again, we just put a palm. Our system detects the contour and the key boundary points, and then it detects the region of interest, and like then it processes it by showing the how I showed in the filters. And here we come to our results. Sorry, we have compared our model to 4 different other public vein recognition models. Our is the last one, proposed CNN, and we have compared them by 4 metrics: is accuracy, precision, F1 score in inference time. And as you can see, our model shows the best result in accuracy, precision, and F1 score. The inference time, it's not the best, but it's still very competitive comparing to others. It's not like the worst, and it's not the best one. So these are the directions that I would like to move on in future. First is addition of artificial intelligence, because in order to face limitations, for example, still in Palm, we may have some, in images, we may have some dirs or cuts that can affect the result. And I think of adding artificial intelligence to face this limitation. The second is enhancement of existing model by training it or on a bigger size of the data set. And the third one is creating no contact system. As I said, I have used a public data set, but in future I would like to build my own hardware with a near infrared sensor in order to collect my own data set and test and use my this model in real life. And the fourth one is production release. This is the reference, the list of literature that I used in my paper, and thank you for your attention.
I have several questions. If you know, my name is Kaulia Manjolova. I'm head of the Department of Intellectual System and Cybersecurity. I am really, this is very interesting research, but I have one question. This is very important in my own opinion, because usually we use just only fingerprint, but in your research you use full hand picture. And do you compare the size of the fingerprint picture and size of the file of full hand? Because this is very important parameter for identification.
You mean the difference in the size of
Size of the picture, yes, size of the picture. Because picture of the fingerprint, this is very really teeny and work very faster. But in your research you use all of the hand print. Of the hand print, this is more bigger size if comparing with the fingerprints. Do you compare the size of the files in your research? What is the benefit of your research is comparing with the fingerprint identification?
Yeah, I understand. First of all, no, I haven't really compared them in my work, but still, I think that we don't use a whole palm for like the recognition process. We take the region of interest that is like the little square in the middle of the palm, and the yeah, it's still it might be bigger like by the size rather than the little picture of a fingerprint, but I think it will be cheaper in terms of like hardware in order to scan the fingerprint. I'm assuming that it will be very high cost sensor that can detect all these little prints. But for my work, we can use near infrared sensors that are like that are not that expensive, and it doesn't need that much of little preciseness.
Okay, I understand.
Okay.
About your new sensor, are you planning to use this your methodology in the mobile applications or mobile phones? Because now all of us use the fingerprints for authentication our mobile phones. But maybe it will be problem for you for implement your scanner in the mobile applications. What
Yeah, it
about
might
this?
be. Yes, it might be a problem for using like mobile phone only, but we can make these sensors portable. That little like sensor that you can like. It's not meant for mobile phones. I think it's more will be useful for I don't know, maybe for access in buildings or when you
Okay,
sign
thank you
something
so
in
much.
that.
So thank you so much.
Yes, thank you.
Thanks. Thank you so much, dear Gary. Next, please.
Next paper ready number 266. Seven.
This study was conducted in collaboration with Dr. University, Sinai University, and the National Defense University of the Commonwealth Country. Um, 20th century, the dynamic host configuration protocol was introduced. RFC 2121 introduced the dynamic host configuration protocol to address the challenge of the automated IP address configuration. This protocol remains in use today. So let me briefly review the process, the DORA process, which is the core communication principle on which the HTTP is built. The HTTP client program discover message server requires an offer with IP address and other necessary information. Then client requests to send the request message to indicate its choice. Then finally the server completes the DORA process to acknowledge message. So all of these communication are conducted in plain text. There are no integrity mechanisms or authentication mechanisms. These weaknesses expose the system to several risks. So the logical question would be how we can mitigate those risks. But before that, we should understand what we are dealing with, right? So this led to the formation of our research objectives, which are to conduct comprehensive review, and to examine various methodologies, then carry out clinical tests. So let's start with the attack types. First is the raw DHCP server, when the attacker introduced the fraudulent server, which responds to the discover message with the malicious configuration. Second is the classical starvation attack, where the malicious client responds to the send multiple discover message, can complete the DORA process, and exhaust the pool. The more sophisticated starvation attacks are proposed with Kubali and Tripoli. These attacks exploit the IP probing mechanisms to check whether this IP already in use. So in the client-side starvation attack, the client checks with RP request after the completion of the DORA process.
In this setting, malicious client respond with the reply and then, hey, I already used this IP. And second one, the server check the IP address before offering it to the client. And here the malicious client also reply. To stimulate those attacks, we established two control environments, one on EVNG with Linux machine, second on VMware with Windows machine. After the test bed were set up, we used Yersinia tool, EtherCAP, DHCP to simulate rogue DHCP server and classical observation. But for non-classical attacks, we developed customized script according to the description of all the articles of Docker. So, client starvation attack used with DHCP ICTO, we found out that the full DORA process is incomplete, which contradicts the finding of previous study, although but on the contrary, on the Yersinia-based attack, these findings of aforementioned studies confirm, or observation confirmed that there is no lease of IP address, but a reservation. On client-side conflict observation attack on EVMG with Linux machines, the attack was successful due to the absence of ARP requests, but not broadcasting, but unicasting. So, on the contrary, with Windows 11 machine, the attack was successful and depleted the pool of IP address in 19 minutes. Like 100. So, on EVMG machine and VMware machine is both of that. The classic starvation attack was successful, but we found out that the behavior of DNS mask DHCP server, first of all, it broadcasts our requests and ICP probes, but it offered the IP address, even received the reply that this IP already used. But on a Windows server, it hasn't been visible from the beginning because of absence of our request. So we achieved our research objectives, and our findings can provide valuable insight to how to conduct these attacks, and also behavior of various services, and to identify which services are vulnerable for these attacks. And after that, we have a consideration that the future research could build on this work by exploring mitigation techniques and then identify which mitigation.
To use them. Because this is cybersecurity, our department topic. Okay, I want to ask why you choose the DHCP attacks? Because usually very popular types of attacks, this is DOS attack and DDoS.
The malicious client sends reply, yes, and the legitimate client can obtain the IP address. It's not attack for the client. Here,
and in which area you are planning to use this
actually, it could be helpful for network administrators. We can inform them and how to establish the mechanisms to mitigate those risks. And
question that following for previous. What is the cost? Cost. What is the economic efficient?
Commercial.
Commercial.
It's not a product, actually, it's just findings that we simulated on that. And about just information, useful information for the network administrator and other
We don't know what is the economic efficient. Maybe you're planning to go with it.
Maybe after we will start the implementation techniques, after that we can, thank you for the idea.
Very good idea.
Okay, thanks for your report. Next, ID number 271. Please join us and share.
Good afternoon. Do you see my screen?
Yes.
Do you see me?
Yes, we can hear you. We can see your screen.
So let's
So,
start.
Mohammed, you
So-
can start, but can you increase your screen, please? And
Oh,
don't
okay,
forget,
of course,
yes.
of course,
Yes, and don't forget about time limit of 7 minutes.
of course.
Thanks.
So good morning, good afternoon, everyone. My name is Din Mohammed. Today I'm going to present our work. It's titled Prototype Implementation of Fingerprint Scanner with prospects for blockchain and LoRaWAN integration. Motivation problem statement. Traditional biometric systems are often centralized. It's meaning that if have a kind of database is breached, all user data is a risk. They're vulnerable for spoofing, data leaks, and single point of failure. So at the same time, many regions, especially remote or rural, lack reliable internet, which limits access to secure authentication technologies. So our goal is to build a system that address all of these pain points. So fingerprint for identity, blockchain for decentralization, LoRaWAN for long-range data transfer. So without Wi-Fi or cellular networks. Before building the system, we conducted kind of small survey with over 100 participants. The results were eye-pointing. 88 prefer fingerprint recognition over password. 77% are aware of blockchain and trusted security, while 70% had never heard kind of LoRa. So we need to change that, and 19% say that they would try a system like ours. This confirmed our assumption. People want secure, modern authentication, so let's continue. Here's how our system works at a high level. We use AS608 optical fingerprint scanner. Which connected to Raspberry Pi 4. When a fingerprint is scanned, features are extracted and hashed using SHA-256. The resulting hash is stored and verified on blockchain. All communication is done through LoRaWAN, which transmit data over more than 15 kilometers. The same device can perform both registration and verification, so you can see the wiring and flow on the diagrams. The fingerprint processing, the pipeline includes several steps. That image pre-processing with Gaussian smoothing, Gabor filtering, binarization to reduce noises, features extraction based on minutiae like reach endings and bifurcations. The features are then turned into a unique template, which is hashed. This helps ensure consistency and accuracy when the fingerprint is scanned under different conditions. Blockchain integration. So why blockchain? Because we don't store raw fingerprints. We store only SHA-256 hashes on a Prometeo-based blockchain, which make our data immutable, tamper-proof, transparent, and auditable. Even if someone accesses the blockchain, they cannot reconstruct the fingerprint, only a hash exists. We also support smart contracts to automate access decision, so the access is granted only when hashes match. LoRaWAN is a low-power wide area communication protocol. It doesn't need a Wi-Fi or mobile networks. So here's what the process looks like. The user scans the fingerprint Raspberry Pi, generate a hash. The hash is sent with LoRaWAN to the backend. The blockchain validates the hash, and the system returns to access decision all about 750 milliseconds. Actually, this makes the ideal for industrial zone, field hospital, or border checkpoint. More deeply in our, which I mentioned, uses cases. So the factory access control, it means that managing employee entry without relying on internet infrastructure, mobile vacation units identify people in remote areas, reliability, border checkpoints, for example, offline ID validation using the LoRa transmissions, and kind of advantage that works without Wi-Fi or cellular network. We tested the prototype in over 100 trails. Here's what we achieved. The false accepted rate it's 2%. False rejected rate it's 4%, and equal error rate is kind of 3%. It means that better than many commercial systems. Average time per scan under 1 second, so power usage was kind of 350 milliwatts ideal, 518 milliwatts during scanning, and 120 milliwatts for LoRa transmission. The full authentication process completes, it's under 1 second, suitable for real-time application. The system's key power with using Raspberry Pi with LoRa, LoRa communication also showed in the table second. The comparison of authentication system shows in the table 4, which compares the traditional centralized system and our solution. So to conclude, we developed a working prototype that proves feasibility of combining biometrics, blockchain, and LoRaWAN. It is decentralized, secure, offline capable, and energy efficient. In the future, we plan to add deep learning for more robust fingerprint enhancement, integrate with EID systems, test the scale in real-world deployment. So thank you for your attention. I'm welcome to answer the questions.
Okay, I have a questions for you.
Thank you for your interesting presentation. So, our general questions. So, what is the most difficult part of your research, and what is the novelty of your research? Because I've seen about the experimental results. Can you analyze? Did you analyze some effectiveness, or maybe you have a high accuracy in your job, in your work?
Yes, of course, it's a good question. Actually, we kind of analyzed our project. We analyzed it, we compared with different traditional secure methods
Yeah.
for authentication, and the combination of biometric, blockchain, and LoRaWAN. It's a kind of unique system because for remote assessing, it's will be kind of usable. Yes. It's kind of yes, I can say that. But the most challenge for us, it was more give kind of more research to in the blockchain sphere, because we have a lot of algorithms which decentralized the system, a lot of hashes. So we choose SHA-256 because it's more usable, easier to implement, and that was kind of the most challenge part.
Okay, and also you have mentioned about the future work that you will use a deep learning neural network. I guess it will be more related for your research work, because you can compare different types of the neural network models and the blockchain, compare it and detect, overview the most effective model for the security. And also, good luck and best of success for your future work. Thank you.
Thank you.
So thanks a lot, Mohammed. So we don't have afters of ID 274, and we can continue with the ID 277.
So hello everyone, do you see my screen?
Yes, sure. You can start, please.
Yes, so my topic is about IoT and the machine learning driven intelligent warehouse mentoring, expanded case study. So as you see that nowadays, the digital transformation of agricultural storage system is crucial to reducing post-harvest losses, especially in areas with extreme climate conditions and connectivity issues such as Kazakhstan. So in this study, we presented IoT-based intelligent warehouse monitoring system utilizing the LoRaWAN enabled sensors, edge computing, and machine learning algorithms to enhance, to change the environmental control and the predictive maintenance. So one of the there are several reasons we have with this kind of motivation, because it's been our previous expertise. We've been doing some projects in the warehouse, so we are seeing following challenges in the warehouse management. It's very inefficient monitoring, and the environmental conditions like temperature, humidity, CO2 levels are being fluctuated in the warehouses, as we have seen in the past, and also high spoilage rates due to the uncontrolled storage environments. That's also one of the big losses in the warehouses, because by the time it comes with the inventory, the material, with its agricultural or some other, it gets rotten, it gets bad, and it's subject to be scrapped. Also, the limited availability of the cost-effective IT solutions in the Central Asia, not only in Kazakhstan, because we are seeing that in the past, even last year, we had one of the digital transformations related projects to be shut down because due to its cost. So one of the reasons is to show that this kind of IoT implementations supported with machine learning algorithms could help and enhance the warehouse management. So motivation would be the need for real-time, automated, and scalable monitoring systems, demand for, of course, machine learning-driven predictive analytics for proactive decision-making. So in the end, the study is targeting also for some kind of expert system that could show to the warehouse managers, employees to do better optimized decisions. There are only with this small scope, 16 studies, recent studies were started. Key findings would be like IoT integration in smart warehouses is growing, but lack of affordability, just like I was telling you earlier, in the Kazakhstan and also in Central Asian markets. Current solutions have limitations in real-time processing and predictive analytics also. Research gaps limited studies combining LoRaWAN-based IoT and machine learning for warehouse monitoring in harsh environments. Lack of cost benefits analysis for such implementations in agribusiness. So we have proposed following architecture. Just like I see, we have used ESP32, BME 688, most affordable sensors to gather the incoming data. Then we use the LoRaWAN network, just like previously was mentioned. That's one of the most affordable network systems that could run in the industry zones because of its low power usage and its long distance connectivity, like up to 15 kilometers, right? And Z19B sensor, it was used to monitor the CO2 concentration levels. ESP32 was used is just for the edge computing, and the BME 688 sensors are just for measuring the temperature, humidity, and the gas pressure in the warehouse. And in the end, of course, we had machine learning models deployed here. So on my right side, as you see, it's a data flow diagram. Raw sense data comes in, then it gets filtered, transmitted by, of course, LoRaWAN network. Then it goes to the cloud storage. Cloud storage could be also local storage, as we have noticed it in Kazakhstan that most of the small to medium enterprises, they don't use cloud storage. They run it locally in their own servers. That's fine too, actually. But it could have been also, I mean, cloud storage implementation could be a completely different subject and justification for the study. So it's a little bit outside the scope. And then it goes to the machine learning model, the long short-term memory. And of course, it comes to as an alert for the dashboard as like some kind of expert system that is telling what's going on right in the warehouse area. So, so technically we have following preliminary data processing pipelines. We have used some normalization, also some initial setup for types of machine learning, so for long short, for LSTM, for SVM, and random forest. Also, we have some performance metrics implemented here, which is precision, which is a proportion of predicted spoilage events. Recall would be proportion of actual spoilage events correctly flagged, and F1 score is a harmonic mean of the precision and the recall. So spoilage reduction is calculated based upon some spoilage baseline, then it goes to the new spoilage and divided by spoilage baseline. As we have seen, we have run this study in 2 warehouses, so we have some tables already. As you see, it's showing that the spoilage reduction dropped down to up to 30%. Which is, I mean, as a preliminary study, showed a not bad result. On the second warehouse, it showed about 25 to 27%. It's outside of this slides here, but it's in my paper. So in overall, we are running that. The study is showing some good spoilage reductions here. So. LSTM, so long short-term memory model, that's used to predict the time series warehouse conditions. SVM, support vector machine model, classifies the temperature and the humidity thresholds. Random forest was used for identifying anomalies in the storage conditions. So technically, implementation strategy was just the data got collected from sensors, processed from ESP32. We had only one warehouse in the west part of the Kazakhstan that was using it. It's a small entity. So preliminary data got from there, rest got simulated to train a little bit our models. And then, of course, the machine learning models analyze the trends and trigger alerts when anomalies are detected. Algorithm, of course, is run in Python by using the libraries such as TensorFlow, scikit-learn, and of course with NumPy. So by itself, machine learning models performance showed as you see on your screen on the left side of the graph. LSTM outperforms SVM and random forest by average margin of 12 to 15% in the F1 score as our performance metrics. It's showing that its ability to learn temporal dependencies. In practice, the LSTM-based system generates fewer false positives compared to simpler models, reducing unnecessary ventilation operations and associated energy costs. Of course, it all needs to be studied a little bit deeper, because we have also, based upon this expanded study, we have noticed that each warehouse it needs to be studied uniquely, because each one has its own unique environments. So in the end, as we see that return on the investment, we have of course the prices, cost, everything is out there, and we have noticed that within 14 months we can get the return on investment when IoT could be implemented versus traditional way to run it. So it's showing that nowadays IoT implementation, it's becoming affordable, even affordable for the small and medium sized enterprise companies, like in Kazakhstan and in Central Asia overall. Big companies, of course, they have a bigger budget. They can do even a little bit more implementations, such as IT ecosystems. But we have studied here small to medium sized enterprises, which with number of employees less than 300, and we are showing that such kind of warehouses could implement the IoTs at affordable cost, and it could pay you back a lot faster. So, in conclusion, the present IoT-driven agriculture is empowering by LoRaWAN sensors, and which is obvious option nowadays. Solar power and integrated ML machine learning models could reduce the grain spoilage in storage warehouses. Empirical evidence from 2 pilot estimations in 2 different warehouses indicates consistent spoilage reductions up to 30%, which is also shows as a return on investment under 1 year. Like one warehouse showed as 7.1 months, and another one, just like we showed, is 14 months as a payback period. So superior performance of LSTM model from the machine learning models underscores the importance of modeling temporal dependencies in sensor data. Bridging low-cost hardware, robust network protocols, and advanced analytics, this approach promises broad applicability in resource-constrained warehouse related to agricultural environments, which is showing the better options in the future, which when we could implement the IoT and the machine learning models in the small to medium warehouses. Of course, there's also some future works need to be done, which would be expanding the machine learning models for better predictive analytics, enhancing energy efficiency of sensor networks, integration with cloud-based analytics platforms for Industry 4 compliance. Industry 4 by itself, we are seeing also it's a little bit falling behind in our warehouses, particularly in Kazakhstan. So it's a good digital transformation supported with IoT and machine learning algorithms. Investigation of blockchain-based traceability for supply chain validation could be also one of the very straightforward and transparent ways of handling the materials inventory in the warehouses. Experimentation with edge-based federated learning, minimizing the data transfer to the cloud, also could be one of the options that could be learned in the future. And just like we have learned from some other papers, we are seeing other approaches, such as evaluating the feasibility of implementing digital twins and the 6G enabled for Industry 4.0 frameworks for predictive maintenance and advanced analytics. Thank you very much. If you have some questions.
I have a question. So thank you for your presentation, but I have missed some details in your research. I mean, today is a trend to use AI, machine learning methods, different kinds of the convolutional neural network, recurrent neural network, and deep learning such as. So I guess it will be more suitable to present some graphics, I mean, that use confusion matrix, how many samples recognize it, and how many amount of the data sets you have used for the training and test to display these results. And actually how you can achieve some results, which novelty you have in your research.
Yes, I completely agree with you. AI is becoming very popular nowadays, but as implementing it as part of the Industrial 4.0 approach for the manufacturing areas, as part of the IT ecosystem, is yet to come, but we haven't studied, we haven't touched the AI approach for this kind of implementation. As also, our target, just like I was referring, was for small to medium-sized enterprises. So they're very limited to the budget. So if like we could come up with AI approach that also gives, could drive some extra expenses, like building local data centers and et cetera, et cetera. That's why we came from the approach of affordability, but in the future, definitely AI should be also learned. In terms of data set collections, it's still taking time. It's undergoing because we just started this during the December last year, January this year. And real data learning takes some time. But definitely, you're right. Data sets and with samples, it's yet to come in the future.
Is your research single or you have a team project to implement this research? I mean, maybe state in the state programs, or you just using that overview?
Unfortunately, yes, it's single based upon my past experience. I have spent like 15 years working in the warehouse, production systems implementations in the past. So as I have started my PhD program, I'm learning it as myself because there is no project, unfortunately, any budget for that. That's why it will be moving, but it will moving slower. But that's a good point. With my advisor, we are doing it as single, based off of the data I have already in my hand in the past.
Yes.
From the past.
Thank you. Good luck and best success.
Yes. Thank you.
Questions? We have one more question.
The speaker asked first. My name is Anita, and it's just architecture. You propose just architecture, or you have some prototype of your monitoring system and experiments results.
This is just the beginning. It's just a small, implementation wise, it's just a small portion of it, which you can implement right away. But if you want to integrate it to your local IT architecture, which already exists in your production company or in the company, it's a different story. That side integration between the LoRaWAN integration, everything from our side, and it's connecting to all of the existing IT architecture hasn't been studied. It's a little bit outside of the scope. So in terms of combining it into the existing IT ecosystem, it's a little bit outside of our approach. But in the future, definitely, final target is to connect it with the ERP system, so that when you have a warehouse module which has such kind of functions, telling you, giving you some kind of predictive analytics or predictive alerts, that would be the perfect result in the end of the study.
Oh. No, my question is about maybe you have a small prototype with the sensors, with the system.
Yes, we had it. We assembled it only once back in 5 months ago, and that's it. We have disassembly. Technically, yes, you can say we have a prototype. But we have run it only 1 month, and then we took that data and we simulated on top of it. But definitely, it needs to be run. The problem was in 2 different warehouses, completely 2 different conditions. Square meters, environments, like warehouse in Almaty and warehouse in Atrau, they are completely different. Especially if you take agriculture conditions, they got rotten a little bit differently. The temperature, how you do it, the pressure over there, weather conditions, everything is depends. That's why prototype was, we can have one prototype, but it still needs to be implemented uniquely in each warehouse.
Okay, thank you.
Thank you.
So let's continue. Now we have our ID number 284. Madia Asset, if you are ready, can share your screen, please.
Okay, I am ready.
Thanks.
Can you hear me?
So, dear participants, please respect our time limit. Okay, we have 7 minutes.
Of course. So, can you see my presentation?
Yes.
Dear participation, IEEE assist. My name is Aset Ahmadia. Actually, this presentation belongs to my wife, PhD student, Marjan Kusainova. Next. Kazakhstan suffers from annual spring flooding due to combination of factors including snowmelt, river ice jams, and the country's diverse geography. The most affected regions typically include northern, western, central, and eastern Kazakhstan, where large rivers such as Ural, Irtysh, Isil, and Tobol overflow due to excessive runoff. The Kazakhstan government has been actively working to mitigate the impact of annual spring flooding through the combination of infrastructure improvements, emergency preparedness, and the advanced forecasting technologies. In Kazakhstan, the northern part has three spring flood zones, which includes Akmola, North Kazakhstan, Kostanay, Pavlodar regions. Remote sensing data is available for flood monitoring in Kazakhstan through various satellite programs, radar systems, and open access datasets. By using satellite imagery, radar data, and geographic information system, authorities can track floods, predict future risk, and develop remote sensing technology has become crucial tools for flood monitoring, forecasting, and disaster management in Kazakhstan. Especially Sentinel-2 and Landsat-8 can be download free and used in many fields, beginning with agriculture and ending natural disaster. But they have limitation. It is cloud core, which makes difficult to see the surface on the Earth and the objects on the that are behind the canopy clouds. Optical remote sensing of Earth is carried out in various optical spectra from the ultraviolet to the thermal infrared range. They are multispectral or hyperspectral. Radar remote sensing data doesn't have such drawbacks as the optical quality of imagery doesn't depend on weather condition and day and night. Today there is Sentinel data, remote sensing data from European Space Agency, which has been available since 2014. Objectives of research. This research examines the Sentinel-1, Sentinel-2, Landsat-8, and multispectral and radar remote sensing data for detecting flooding houses and buildings. There are result values of spectral bands for separating water bodies from non-water bodies, which are calculated from the intersection of histograms. Results are necessary to obtain binary images. These binary images are logically summed to find a common fused binary image by using software for remote sensing data processing. The purpose of this study is to determine the flooding zone, including using remote sensing data, Sentinel-2, Landsat-8, Sentinel-1 radar data to evaluate the spectral band polarization channel and their result values, which is better to distinguish the flooding and estimate the number of flooded houses using GIS data in creating flood map. This is the my affected region of Atbasar town in Google in white rectangular outlines. For my research, we use Sentinel-2A and the Landsat 8 optical data is this data, Sentinel-1B RadarSat data. So we use some speedology intersection method to divide water body histogram classes and the non-water body histogram classes. This is our algorithms in figure 2, algorithm of processing remote sensing. It is this subsequent process, subset data, atmospheric correction process, geocoding and changing pixel resolution, calculation, threshold value, formation, binary images, logical summation of binary image, creating flood map, and finding affected house. Using some Python scripts, we calculate threshold value for each sentinel to a band. So after so this is our results. Calculation binary image. This is dark. Dark in the water body classes and white non-water body non-water body. This is the original image. So we have some this is the different. This is the image different spectral is for band 12, band 6 Landsat 8, and the original image by Landsat band 11, and for Sentinel VV polarization binary image. After creating binary image, we use some formulas to some techniques, logic summation techniques to and we get we obtain some image, this image, fused image. So after that, we are superimposed and on GIS data to find some flooded house. In this, we see in this slide, we see red color. It's buildings, houses, and something. The allocation of water surface according to conclusion, according to the optical remote sensing data from Landsat 8 and Sentinel-2 is better carried out in the infrared range from near to the 945 nanometers to thermal infrared 12,000 nanometer in the absence of clouds. With existing optical remote sensing data from Landsat 8 and the Sentinel-2, it is impossible to accurately determine flooding of the eastern part of the town of Atbasar because the spatial resolution of these images is less or comparable to distance between houses and building. In addition, building and the houses may cast the shadows. They may be partially flooded, and this may also cause additional recognition errors. The Sentinel-1 remote sensing data shows the best detection of the water surface using acknowledgement. This research is funded by Science Committee of Ministry of Science. This project AP for 4034 86 167. So thank you for attention. Questions?
Question, colleague.
No.
Can I ask about in which stage currently the process, and are you planning to maybe create some informational system, monitoring system?
Do you mean geographic information system, maybe a web portal?
Yeah, like a portal.
In future, in future, we will plan to create some that web platform for our. No, this is we use basically free available Sentinel-2, Landsat 8, and other European space emergency satellite. You know about Kazakhstan satellite. KazYosat 1, KazYosat 2 is also not available, just via request, maybe it is available. So I will, we will design and create some web platform for all the data on the and also Kazakhstan's satellite group.
Thank you. Yes,
Yeah.
thank you.
Your report. So we have one more. Yes. So we have one more presentation, ID number 289, Aruzhan Mektibayeva. If you are ready, please.
Hello, I'm ready.
Excuse me.
Maris, can you stop sharing?
Okay.
Thanks a lot.
Mhm.
So Aruzhan, you will be given 7 minutes, okay? And
Okay.
Yes.
Can you see my screen?
Yes, we can start. We can see your screen. We can hear you.
So, good afternoon, everyone. My name is Aruzhan, and today I'm going to present our research titled Adaptive Machine Learning Algorithms for Data Preprocessing and Transportation Systems. So this work was conducted at Astana University, and this is a part of a national research project funded by Ministry of Science and Higher Education of Kazakhstan. So our research is focuses on the forecasting of real-time passenger flow in urban transport system. So with a case study based on Astana's public bus network. So firstly, I can share with some facts about in recent years public transport systems have become more complex and data intensive, as we know. So cities like Astana face unpredictable passenger demand, especially during peak hours, when bus occupancy is more than 90%. So traditional forecasting models such as ARIMA or starting decision tree ensemble, so cannot effectively respond to data drift or maybe some changes or challenges connected with weather and traffic disruption. So therefore, the goal of our study is to design a lightweight adaptive machine learning pipeline that supports real-time retraining, and also we experiment with and compare different kind of models, and we will talk about it later. So let's talk about literature review. So literature review was conducted by using some researchers' articles in big databases like Scopus, Web of Science, IEEE conferences, and also on. And so prior work in this field has shown both progress and limitations. So traditional time series models like ARIMA are easy to interpret, but fail under nonlinear and dynamic data. Neural and graph-based models such as transformers and spatiotemporal graph neural networks offer better accuracy, but also have some limitations, they require significant computational resources, large volume of label training data, and are difficult to deploy in real-time environment. Meanwhile, adaptive learning is still underexplored. So our study addresses this gap. So let's talk about dataset that we used. We used real-world data provided by Innoforce, a transit tech company working with Astana transport network. So the dataset includes 22,000 records collected over 2 months and 28 bus routes covering like GPS, telemetry, occupancy levels, boarding events, routes, and stop identifiers, and also on. So the first stage was we implemented a multi-stage cleaning of data cleaning process, which corrected because we have some missing timestamps, like some missing values, logical inconsistencies, and in passenger counts, and also some different kind of anomalies like occupancy drift and also on. So here is a model selection and comparison. So in this experiment, we tested 5 different models, each with a specific role and expected strengths. It's a XGBoost, temporal, conventional network, adaptive ensemble trees, linear regression, and ARIMA. So what we see in the result is AAT had the best performance overall because it has the lowest this kind of metrics, and its drift responsibilities has only 56 seconds. So it means that it was able to detect and adapt to change faster than any other models. This result shows that this model is the most suitable model for real-time transport systems. So here's a feature importance and evaluation metrics. So as I said before, sorry. So in this slide, we can explain what kind of features we use it. It's temporal features, occupancy dynamics, location context, and also categorical encoding, and also I said about normalization and the evaluation metrics and their role, like mean absolute error, it tells us the average absolute error. And also we used new metric RCAI. It's our custom metric. It compares the model error during drift and during the stable periods. So lower RC means better resistance to change. So this combination of engineering features and advanced metrics allows us to train models that are both accurate and robust.
Arjan?
Yes. Sorry. I cannot move to the next slide.
Okay, please continue. Can move or some problem? Okay.
I have some problem.
Okay, we will open your presentation here and we can share it, okay? Нет ее? So maybe some conclusion or what? Yes, maybe some brief summary of your work.
Okay, so brief summary. So we design a pipeline. As I said before, it's main part of our work, like pipeline architecture. So here's some different kind of parts, and as I remember, data ingestion via Apache Kafka. Then we will preprocessing and feature extraction, and drift detection, and then incremental retraining is also important because we replace only underperforming trees in the ensemble, saving the time and the resources. And then real-time evaluation. So we look performance continuously and alert if the model starts to degrade. So this keeps the system stable. So key achievements. I can say like why this work is important because it's like has the importance in transport systems. Like for cities like Astana, the city can help reduce overcrowding, plan roads better, and improve commuters like experience like work better. For researchers, it can help to know what kind of models were used and why, and what results they can show. So, like summarizing and maybe for self-updating models. For the future, it shows how machine learning can work in real life, like not just in theory. So it's all. Thank you for your attention.
Thanks a lot for your report. So I have a question for you, Rojan. So can you also tell me what kind of machine learning algorithm you use and why did you choose this algorithm protocol? Sorry, machine learning algorithms. How can we make a choice?
Okay, so we used different models of machine learning. First of all, it was XGBoost, and so it was chosen as a state of the art ensemble model. So we use it to like retrain, and because it will be done manually on the full data set. So it was accurate, but could not adapt in real time. So then we used temporal convolutional network (TCN). So it was selected like as a deep learning model for time series. So then we used linear regression and ARIMA. It's like traditional models. So like classical time series baseline. So it performed very poorly on our data because we have like dynamically data and it has more features than usually. It could not like handle with this data. Linear regression also was used. It's also like simple baseline model. And the last one, which is the best one, is adaptive ensemble trees. IT. This is our proposed like model. So it was designed to retrain incrementally.
Okay, thanks. Any questions, please? Okay, one more question.
In the beginning, you said about that this research part of the Big Science project, yeah? And how you're planning to implement your results, maybe in real life, in real transportation system?
So as I said, we had a real-world data set, which was provided by Innoforce. So every month they give us new data, and we can like test it with different kind of data. So it can show us like different results, and we can summarize some insights and do it better, like train the data or train the model more perfectly.
About implementation, the question was about the implementation, the results.
Implementation the results. So these results shows us that not every model can handle with a dynamic data set. So do you mean this one? Because we summarize it and like choose and find out the best model, and these results can help us to not like repeat our mistakes in the future.
You.
Okay, thank dear participants for joining us. Now we have a break and then we'll continue. Thanks a lot.
Mm.
reproduce those results. These are the open source models used for the research agent and knowledge base. So on each of them, about 400. Next slide. So on this slide, we're showing the bar graphs of the accuracy and trustworthiness in comparison with the overall score. We're not showing the response times here. And we can see how there are various interesting correlations between the two. So to conclude, our positive findings of accuracy, trust, and responsiveness certainly show that there's potential in developing the system further. We had valuable responses to suggested inquiries. We had an increased security, of course, because it is entirely offline. So there's no online dependencies. We're not using ChatGPT or any of the other online large language models. This is entirely offline. And of course, because of the enhanced retrieval of enterprise knowledge, there's improved business decision making and resilience against over amnesia. Thank you.
So please, colleagues, questions?
Told me that we should be speaking to this. Yeah, thank you. Absolutely. So thank you so much for your research work. I have two questions. One is more of a clarification situation question, and the other one is what are your future avenues as a continuation of this project? Where are you looking forward in terms of what you already established, where you're going with this that finding? And the first clarification question, if we can roll back to the slide that was on the accuracy. So you were mentioning a little bit backward. Okay. So there was a slide on the accuracy, and you were, yeah, this one, and you were saying that so rows 9 and 10, they show, you know, a score of 0.46. So you were mentioning that there is a potential in the accuracy of the overall data set. So I was a little bit confused. Does this mean that you are not really going for overfitting because your highest score is 0.82? Or so basically, can you clarify on the 0.46 and why you're satisfied with these numbers?
Thank you very much for the very valid question. I'll start off with the last question and then move on to the future plans. So my justification for why 0.46 is not a terribly bad score, because over 11 months we would have expected to see more contrast between the best score and the worst score in the upper levels. So we were expecting to see something like a 0.2, for example. So the fact that it's 0.46, not much worse, is encouraging. That there's definitely potential for developing this further. In response to your first question, certainly multimodality would be the area which we'll be focusing on. Right now, we're looking at purely textual documentation. In future, we would like to investigate the potential of using multimodality, so visuals, video content, audio content, etc. Thank you very much. Thank you.
Так, so we will continue. Next, we don't have authors of 314, and I think we'll continue with their ID number 323.
Good afternoon, distinguished colleagues. I'm Oleg Rybushuk from Uzhhorod National University in Ukraine. Today, I will present our research on optical filter interface and homogeneity and our innovative web-based modeling solution. This work addresses a critical gap between the theoretical filter desire and manufacturing realities that affect the precision optical system worldwide. As a core challenge, we addresses in the significant discrepancy between theoretically desired optical filter and the manufactured performance. While conventional design assumes perfect sharp boundary between the layer manufacturing processing create gradient transmission spanning 3 to 5 nanometers. This seemingly small intersection cause measurable performance degradation, including a spectral shift of 1 to 2 nanometers and a bandwidth alteration of 5–10%. For high precision application like the spectroscopy, laser system, and telecommunications, this division can compromise entire system functionality. Our objective were to develop a comprehensive web-based platform that modeling this realistic interface and homogeneities, quantify the effects of optical performance, and establish design methodology and that account for manufacturer realistics, effectively bridging the gap between theoretical design and practical implementation. Our approach employs a matrix method for analyzing multi-layer instruction with inhomogeneous interface. For each layers, we calculate a characteristic matrix combining the preceding interface region, central homogeneous region, and subsequent interface region. We investigate 3 fundamental refractive index distribution representing different physical mechanisms, step like distribution using the Heaviside function, linear distribution with the gradients change, and exponential distribution that closely matches experiment observation in real coating systems. The analyze who representative filter configuration as 70-layer broadband filter for the 400 to 700 nanometer range and a 70-layer narrowband filter optimized for 616 or 630 nanometers. Our web platform implements this theoretical framework using a client-server architecture with adapted discretization and parallel processing for effect calculation. Our analysis revealed the distinct pattern in how interface profile affect filter performance. For the broadband filter shown in this graph, you can see the transmission spectral different across interface type. The linear interface profile demonstrated the highest maximum transmission at 99.34%, while the exponential profile showed superior stability with a maximum transmission of 89.73% and improved anti-refractive properties. For the narrowband filter interface, effects were more pronounced in peak wavelength position and bandwidth. The step interface includes the large peak wavelength shift of plus 1.5 nanometers, while the exponential profile maintained the closest assurance to the desired wavelength with maximum shift of only plus 0.3 0.3 nanometers. Bandwidth increased from the desired specification of 35.2 nanometers to 67.8 nanometers with step interface, 7.4% variation that can be critical in precision applications. The most significant finding was that exponential profile consistently provided the most stable spectral characteristics, suggesting the alignment with natural occurring interface of formation processing. Our research has established quantitative correlation between interface profile and spectral performance, demonstrated that exponential interface provide superior stability across both filter types. This insight suggests optimization opportunity in deposition profile to promote gradual materials transmissions. Most importantly, our results show that interface effects should be viewed not just as a limitation, but as engineering parameters. By considering this effect at the initial design state, manufacturers can achieve highest first pass success rate that with the traditional approaches that assume idealized interface. Our web-based platform, accessible via this QR code, provide researchers and engineers with accessible tools for modeling this effect and optimizing filter design. Future development directions include extension to oblique wire inside and polarization effect, natural network optimization for interface parameter, and integrated with manufacturer control system. I would like to acknowledge our research team members, Alexander Mitsov, Volodymyr Mitsov, Joseph Lovatsky, Alexander Levchuk, and Vasil Petsko, who contributed to this work. Our web platform is accessible at opticallayers.website, and you can reach me via the email shown on this slide. Thank you for your attention. I'm happy to answer any question about our research or platforms. Thank you.
Thank you very much, first of all, for your nice presentation. I have one question. So you say that you presented, first of all, very interesting techniques. I mean, the approach and methodology, yeah, based on the web design, web development platform. So do you consider another types of the approach? I mean, like hyperspectral, for example, imaging, yeah, the technology? If yes, did you consider and compare these two types like approaches? And my second question, which coming from first one, is about if you consider these two types of the techniques, which one gives much better, I mean, results, like improvements? Yeah. Thank you.
Thank you for your question. Give me 1 minute, please. Yeah, I understand. For the calculation, we are use only the matrix method. It has shown
Can
itself
clarify?
very well in
Maybe.
any other. Please.
Yeah, sorry. I can clarify. So my question about another kind, very similar method and approach. Yeah, it's emerging processing methods and technology, which very closely to the those methods which you propose. I mean, based on the web development technology. Yeah. So did you consider this one? Do you have some comparison? If yes, what types of the differences between these two types of data? Okay.
We used line. In this slide, you show a step line, a matrix method, a linear, and exponential. We used for calculated the matrix method only matrix method in modeling for modeling system in modeling system. Using interference, we used linear, exponential, and step line interface. Only this function, or only this using this function.
Okay, thank you. We have one more question.
Thank you for your presentation. It's a very interesting topic, especially for me, but it's also connected to my topic. I wanted to ask you about this. So, are you using this interface for telecommunication purposes, or are you using it for sensors, as a sensor for sensing, for example, some parameters through optical fiber? I see the material that you are just listed here. So, and I wanted to ask if you are using it for telecommunication, is it could it be used for spectroscopy, for example, or interferometry methods? Thank you.
Please repeat your question. I not heard. Hear all.
Okay, can you hear me right now?
Yeah.
So I wanted to clarify: is it are you using these methods, models and methods for telecommunication purposes? For, as I see that you are listed the optical fiber materials, or are you using it for as the way to sense some as a sensors? If you are using it for telecommunication, could be it used as well as spectroscopy methods and interference methods, maybe like this, or reflectometry methods.
Mm.
The communication type of problem or what? Or he's not hearing what we're saying? He's not hearing what we're saying?
It's okay.
Thank you.
Thank you.
Thanks a lot for your report. So we can continue. Our next ID is number 365, Daniel Nurlanov. We will present this work, please. Daniel, please, can you turn on your camera?
Hello. Sorry, I don't have web camera.
Sorry, we can't continue your report because it's a strict requirement of our conference. Maybe you will fix your problem and you will make a report, your report later.
Sorry. Hello everyone. I'm another co-author. I can open my camera and present myself.
Okay, good. Thanks.
Okay, 1 second. Okay, hello everyone. My name is Azamat. Today I'm going to present our submitted manuscript.
Sorry for interrupting, but no, your camera is, you don't see any image.
You don't see any image? 1 second. You don't see my screen, yes?
That's okay, yes.
Yeah. 1 second. So it seems doesn't work. Do you see presentation? Sorry, do you see presentation?
Yes, Daniel, you can start. Oh, sorry. Azamat, yes? Azamat.
Yes. Okay. Today's topic is intelligent career path recommendations, leveraging blockchain and machine learning. And the authors are coming from SDU, KBTO, and UNU and University de Santiago de Chile. So first of all, let's get introduced to this topic. Actually, currently the undergoing the increase of the need to find a job for students, especially in IT sector. And Kazakhstan is actually implementing a lot of standards to increase employability. However, there are such issues such as currently it's difficult to map specific students to some specific specialty that he will actually like. And actually finding the interest for student is cumbersome. Therefore, we got to the aim of our work, which is to make blockchain-based career path recommendation system that universities in Kazakhstan can employ in order to actually increase employability of their students based on secure, personalized, and data-driven support, which actually blockchain implements. And the objectives of the study are: the first one is to develop blockchain framework. The second is to incorporate analytics and machine learning in order to generate personalized career recommendations, and then to make evaluation of our system. And data sets that we used in this study was collected by ourselves. So we collected it from SDU University, around 692 records, which consisted of information about students, their GPA, what kind of certifications they had, what kind of hackathons they participated, and what are their employment interests, what the fields that they're interested in, what kind of programming skills they are having, and a lot of other factors. And the methodology can be represented in this way. So we collected our data set, then we made a pre-processing, which involved actually removing missing values, also making normalization to reduce biases. And we used 5 machine learning algorithms, such as LSGBoost, neural networks, logistic regression, random forest, SVM. And then we put it into the blockchain system. Okay, 1 second. Okay, and first, when we made our blockchain system, we can see the number of blocks and how many tempered or modified records we can actually observe it. And here we can see that blocks 2 and 5 were tampered with, and the remaining blocks actually enabled integrity, which shows good result in terms of security. And also we made experiments related to feature importance. What kind of features actually contribute to the career choice of students? And we can see that GPA, certifications, and hackathons are the major factors that influence what kind of specialty IT student will take, whether it would be front-end, back-end, or maybe database administrator. And this is the comparative experimental results of the machine learning algorithms that we employed. We employed here several metrics such as accuracy, precision, recall, and F1 score. Considering that the beta class was the target class was imbalanced, we used not only accuracy but also precision and recall And here we can observe the experimental results that we've got. And also we show a ROC curve. And we can see that XGBoost has the highest RIA under the curve in our system. And in the second place, it is neural network. And other ones are also high, but the highest one is XGBoost. And we made a comparison. Currently, simple MLP multivariate perceptron algorithm achieved accuracy of 92%. And actually, it is consistent with the other literature that we found related to intelligent career path recommendation. And also based on the number of temperate blocks diagram that we've got in the blockchain test, we can see that integration of blockchain actually improved security and transparency of our system, which enabled immutability of career recommendations and enhanced accountability and minimized the risks of the data manipulation. And comparing with the other studies, which used only machine learning algorithms, we also put our system into the blockchain system in order to improve security. And as the conclusion, we presented personalized career path recommendation for IT students based on the data set of SDU students. And we employed several machine learning algorithms such as XGBoost, Random Forest, SVM, and other ones. And the highest accuracy was in MLP. The highest area under the curve was in XGBoost. And based on the blockchain diagram, we see that blockchain can actually be used to enhance security and transparency of the recommendation process. However, the limitation of our study is that our dataset is restricted only to SDU University. Therefore, we plan to collect more data and increase the number of factors and in order to validate our system in other universities, whether it can be useful or not. That's all from my side. Thank you for attention. If you have some questions, you can ask.
Okay. Thank you a lot for your interesting report. So any questions, please?
So, thank you for your presentation. I wanted to ask, do you want to could you please
open presentation?
are you planning to combine those methods that you are compared, or are you just going to use only MLP? And what kind of a criteria, how did you form your criteria for this model? Let's say that.
Yes, thank you for your question. Yes, we are planning to combine these algorithms and blockchain-based system into the other universities. And currently, we are thinking about increasing the metrics that we can utilize. Here, we use only the number of temperate blocks in the blockchain-based system. And in machine learning, we use accuracy, precision, and recall. And we are planning to increase our data set, collect data from other universities, and then combine blockchain and machine learning, and to see how it will work in other educational institutions.
Thank you very much.
One more question.
Hello. Yeah, so I also have this question from a practical standpoint. So the input parameters that you used and the output parameters that you also proposed in practical life, and you're saying that your accuracy attained 92%. So just could you give a couple of examples that demonstrate the accuracy of the inputs and outputs, between the inputs and outputs?
Yeah, thank you for your question. We actually tested it only in SDU University because we collected data only from SDU. And we didn't include real life cases into the paper, but we made some use cases. And The input data was a GPA of student and hackathons that he participated, and also other factors. And the output was specific specialty as backend, frontend, database administrator, and other ones. And we can send you some use cases to email.
Thank you.
Okay, thank you.
Now here we will continue with the ID number 366.
Hi everyone, can you see my presentation?
Yes, we can see a presentation. Just a kind reminder, you will be given 7 minutes.
Yeah, okay, thanks. So, greetings to all present. I'm Serhiy Lopolov, a first-year PhD student at the Kyiv National University of Construction and Architecture, and I would also like to introduce the co-authors of the research, namely, SharePoint. Yeah. Vladislav Hots, Lena Fetusenko, and Anatoly Fesan. So we are glad to present you a report on sensor-aware graph convolutional and LSTM model for reliable water quality forecasting. And our work advanced water quality prediction accuracy with significant implications for environmental management. So water quality monitoring faces several key challenges, like sensor with varying error margins that degrade over time, irregular sampling creating data gaps, and complex spatial temporal dynamics. And these factors create a multidimensional predictions problem for several traditional methods, traditional forecasting methods struggle to solve effectively, limiting reliability of current approaches. And existing methods have significant limitations, and traditional statistical methods miss fine-grained dynamics, like LSTM networks capture temporal patterns but ignore spatial relationship, while graph convolutional neural networks GCN model spatial connections but lack temporal context, and random forest handles non-linear relationship but struggles with sensor uncertainties, and crucially non-effectively incorporate sensor reliability metrics into predictions. And our solution combines GCN, graph convolutional networks for spatial modeling, with long short-term memory, LSTM networks for temporal patterns. We directly integrate sensor uncertainty metrics throughout the modeling process, constructing a spatial temporal graph where nodes represents monitoring stations and edges encode both geographic distances and measurement variability. And this provides not just prediction, but confidence interval for better decision-making process. And our pipeline shown in this figure begins with raw sensor data that undergoes preprocessing to estimate uncertainty and handle outliers. We construct a spatial temporal graph integrating this uncertainty measures. The GCN nodes extract spatial features through uncertainty weight aggregation, while the LSTM node models temporal dependencies, and finally our prediction refinement model generates forecast with confidence intervals through ensemble learning. And as the next stage, we have figure 2 that show our study region through the Ulysses water quality viewer and not the dense sensor network along waterways with additional stations across tributaries. And the regions includes diverse land use patterns like urban, agricultural, and forested areas, and each affecting water quality differently. And our monitoring campaigns covered multiple sensors and seasons using various sensor types, emphasizing the need for our approach that handle variable sensor reliability. And our analysis revealed several significant seasonal variations across parameters. In these figures, fall turbidity shows higher values that spring, suggesting increased sediment influx. Spring salinity concentrates around moderate levels, while fall datasets screws lowers. And temperatures are mid-range in spring but higher in fall, and chlorophylla shows more intensive blooms in fall seasons. These variations highlighting the importance of robust temporal modeling in our framework. This figure shows how monitoring sites vary seasonally. Spring campaigns concentrate in northern areas, while fall monitoring provides broader regional coverage, and these variations enables us to capture site-specific phenomena and highlight both spatial and temporal heterogeneity in our data, reinforcing the need for our adaptive spatial model approach. The next figure shows our model's training performance. We see steady convergence of both training and validation laws, indicating progressive learning without overfitting. The mean absolute error follows a similar trends with training and validation curves running parallel, demonstrating robust generalization capabilities. A key advantage of our approach is uncertainty quantification. This figure shows our ensemble's predictive spread for turbidity forecasts, and actual values closely align with central estimates, especially in mid-range scenarios, and higher turbidity even show larger ensemble spreads, reflecting greater uncertainty. And these mechanisms enables stakeholders to coach prediction confidence and prioritize investigation where uncertainty remains high. This table presents validation metrics across water quality parameters we used. Results show strong performance. Turbidity achieved an R2 of 0.88. Temperature prediction were most accurate with R2 of 0.91 and RMSE of 1.13. Degree salinity showed excellent precision with MAE of just 0.48 PSU, and chlorophylla reached R2 of 0.82. And these metrics confirm our model maintains high accuracy across different seasonal and special conditions. And our hybrid model consistently outperformed alternatives with R2 improvements of 9 to 12% over LSTM only, 8 to 15% over GSN only, and 3 to 10 beyond random forest. Go to the next slide. And in conclusion, our GSN LSTM framework addresses foundational challenges in water quality forecasting by modeling sensor variability and integrating spatial temporal dynamics. And the model maintained high exploratory power across indicator, achieved some R2 values. So by incorporating sensor error metrics directly into learning, our approach demonstrates resilience against data reliability fluctuations crucial for environmental monitoring. So thank you for your attention. I will be like to answer any question.
Thank you for your presentation. It's a very interesting and very vital topic for the current state of ecological environment. I wanted to ask you about the method for prediction. Are you considering it like what kind of? First, I would like to know what kind of sensor are you using, and the second, I would like to know how are you? Let's say, what are you using for the reference in for the prediction?
Okay, thank you for your question. Firstly, I want to ask, we used several Delta X datasets. It's open source datasets, as well as satellite images of the respective regions. For comparison, we used image obtained with Copernicus browse and information in these datasets. It was not just a matter of matching images that are not clouded and available for appropriate analysis, and in particularly using the appropriate Copernicus tools. And second question, we used R2 metrics for compare our results in GSN only and LSTM only methods, and we have results in range like 0.88 to 0.92 approximately.
Yes, thank you.
Thank you.
Any questions? No? So thank you for your participation. Let's continue with the paper ID number 384. Roman Mazurenko and Alexey Matsievsky, yes. ID number 3.
Sorry, can you see my screen?
Yes, you can see. Roman, so you can start. You will be given 7 minutes, please.
Okay, thank you. So good afternoon, everyone. My name is Roman Mazurenko, and I'm honored to welcome you to this session. Today, I'll be presenting our research on leveraging deep learning, specifically long short-term memory networks for optimizing resource management in distributed cloud and edge computing systems. This work is a result of collaboration between Kyiv National University of Construction and Architecture and Taras Shevchenko National University. Our motivation stems from two transformative trends in modern computing. First being the rapid expansion of cloud data centers and the rise of distributed edge infrastructures. These developments enable scalable low latency services, but they also present serious challenges. Workloads have become increasingly volatile and unpredictable too. Viral content or real-time analytics can generate massive traffic spikes within seconds, risking system overloads, increased latency, and potential SLA violations. At the other end of the spectrum, infrastructure often remains underutilized during off-peak times, leading to wasted resources and inflated operational costs. Traditional approaches such as rule-based traffic shifting or manual scaling are too slow and inflexible. Static thresholds tuned for yesterday's workloads fall short in today's dynamic environments, and manual interventions introduce delays that systems simply cannot afford. To address these challenges, we propose using LSTM neural networks to learn temporal patterns in server load. By forecasting future demand, the system can proactively allocate resources, improving performance, reducing latency, and increasing energy efficiency. Here we illustrate the model architecture. The system ingests a sliding window of past load measurements, which are processed through an LSTM cell. This cell captures both short-term fluctuations and long-term trends. The output is a prediction of future resource requirements, which informs proactive resource allocation decisions. For evaluation, we use a synthetic time series dataset simulating one full day, 1,440 minutes. The data combines a sinusoidal baseline to reflect daily usage patterns, Gaussian noise to introduce variability, and regular spikes every 200 minutes to simulate unexpected events. We allocate 80% of the data for training and 20% for testing. The model is trained for 100 epochs with a batch size of 32. The architecture consists of an LSTM layer with 64 units, a ReLU activated dense layer, and a final output layer. The model is optimized using ADAM with mean squared error as the loss function. At the heart of our approach is the LSTM cell, which maintains both hidden state and the cell state. Information flow is governed by the forget input and output gates. shown in equations 1 through 5. These mechanisms allow the network to retain relevant information over long sequences, which is crucial to accurate time series forecasting. Here is the model performance. The blue line shows the actual server load, while the orange line displays the predicted values. As you can see, the LSTM effectively captures both baseline trends and more complex fluctuations. The mean squared error on the test set is approximately 10, indicating strong predictive accuracy. We do note a slight lag during abrupt spikes, particularly between time steps 80 and 100. This reflects a known limitation of LSTMs in reacting to sudden unforeseen changes. However, the model quickly stabilizes after the spike and continues to track the load accurately. These results demonstrate that LSTM-based forecasting is well suited for real-time adaptive resource management in distributed systems. In conclusion, our LSTM-based approach improves resource utilization by enabling intelligent proactive scaling. This leads to lower latency, reduced energy use, and more resilient infrastructure. While some challenges remain, particularly in handling sharp anomalies, we see great potential in combining LSTMs with attention mechanisms, transformers, and reinforcement learning to further enhance adaptability and responsiveness. Thank you for your attention. I'll now be happy to take any questions.
Thanks, Bot. Any questions?
Thank you for your presentation. I guess this is much more about methodology, about new approach, new method. So I have questions. Did you consider, or maybe you already have some practical implementation, such as case study, which based on this your proposed suggested method? Thank you.
I'm really sorry, I couldn't hear the last part of the question. Could you please repeat?
My question about practical implementation, I mean, did you consider or maybe already have used some practical like case study, which based on your suggested methods or methodology?
Yes, sorry, the sound is not at all. I believe you were asking about some case studies, right?
Yes, yes.
Okay, nice. Yes, so as you might know, this is quite a common issue in software engineering. Basically, this like server loads and the builds that come after it. So me and Alexei, the authors of this paper, do have some experience working as software engineers, and this is basically the main case where when in a business you use like different clouds, clusters, and so on, and like it would be perfect to have this kind of tool to basically like reduce energy use, lower the bills, and to have just more resilient infrastructure by forecasting the load. So yeah, that's our main use case. I hope that answers the questions because I couldn't
Thanks
hear
a lot, Roman. So we have a previous paper ID authors, 373. Oleg Kurinsky, yes, you can start your presentation.
Yes, I can.
Let me ask you to switch on your camera.
Yes.
Now we can hear you.
So our title is optimization and adaptations of neural networks based on existing architectures. Relevance of study. The rapid of development of artificial intelligence has led to increasing demand for neural network models, efficient, adaptive, and capable of operating under limited computational resources. One of the key challenges in the computational and memory intensity of deep learning architectures, such as VGG, ResNet, and transformers. This model requires powerful hardware, large amount of data, and long training times. Deploying such models in real-world scenarios, especially on mobile or embedded devices, is problematic due to resources constraint. This makes optimizations a crucial step of practical applications, particularly in edge-computing environments. Another present issue is a need for neural networks to quickly adapt to changing conditions and new tasks without requiring full retraining. This is essential in fields like medical diagnostic, autonomous vehicles, and security systems. So our goal to optimizations network comprehensive study of method and for optimizations and adapting neural networks based on existing architectures. We are focused to improve their effectivity, flexibility, and energy using in mobile devices or cloud spaces. Purpose of the study. The primary goal of this study is to explore and systemize modern methods for optimizing and adapting network based on existing architectures. So our key objectives include this to identify the main challenges in applying large-scale neural networks in real-world conditions, especially when facing limited computational resources or data availability, to analyze practical techniques such as model compression, transfer learning, quantization, and planning for improving model efficiency and flexibility, to demonstrate how pre-trained modules like VGG16 can be adapted to new tasks with minimal training and
according to our rules, it is not allowed to read all your text. Please, can you speak in your own words?
Okay. So in my own words, the main task of our study is to optimize network and we are focused to do this on to do this on existing architecture. For example, in our study, we want to learn model with GG16, what teach on ImageNet. We want to adapt it to detect image from database CIFAR10. So for do this, we don't create a new network. We don't create a new neural network. What we do, we delete. What method we use it? We use it. Wait a moment. We delete another layer, create new layers. We froze the layers what we need, and use optimizator add-on. On this slide, you can use a table what show steps what you need to do. So it's loading data pre-processing, creating a model, compilation, and model training, and the results. Here you can see text that here on this slide show a code for our work, and here is model adaptation using VGC 16. So here here you can see how this code is works. So it's these right steps for this code. It's pre-processing, it's normalizing using pre-processing input, and next is importing VGC 16 without top laters, how I say. So it's include top, false, weight from ImageNet, freezing base models weight, and edit new laters, compiling with Adam optimizer, and train it for this for 10 epochs with using image data generator. Here you can see a training result. So it's firstly the initial accuracy 10%, after one epoch 16, and after 10 is 92. So it's a loss as initial loss 2.3, after one epoch 1.2, and after 10 it's lower than 0.4. Here you can see the table that show comparisons, future and perspective. So how we see this? We see this perspective because in our time, neural network become bigger and bigger. They need in a lot of places. And for example, in mobile devices or cloud data, it cannot be used for normal because it requires a lot of resources and many things. Because of and for this reason, optimizations of neural networks, it's a very perspective and big way to study, because it can allow devices with low resources use neural networks. In conclusion, I can say that our optimization VG16 has retraining new layers. The most impactful techniques were retraining the upper layers and applying data augmentation. There is a certain trade-off, 2.7 reduction in accuracy enabled nearly, halving the model size and process time.
Thanks a lot. Any questions? Okay. Have a questions for you?
Thank you very much. It's very interesting. Once again, some methodology approach. So it most looks like more theoretical, but of course, each suggested method approach should have some practical application or case study. So you say that you propose some optimization, yeah, based on the neural network. My question: which model? I mean, which are the practical processes, yeah, you consider the model of the practical process, which one? Because maybe I didn't hear very well, so just clarify, yeah, based on what types of the processes of production or another types of the case, you made some optimization based on the neural network technology, yeah. If you have some practical like case study, once again, just give them. Thank you.
I didn't hear so good. Your question is what model we use it or what?
Yeah, I mean what the model of the what types of the objectives, yeah, model of the first of all some model, physical, then mathematical, then you propose the line.
In our study, we used a model VGG16. It had pre-trained on ImageNet, and we adapted it for classifying images from the CIFAR-10 and optimized it on the way using a method that I told we are writing layers that we need with frozen layers that we don't delete all the layers, we frozen layers and rewriting some layer and then using optimizator Adam.
Thank you very much.
So we'll continue with the paper ID number 388. Yes.
Thank you.
388. Ömer Serk Kablambek, yeah? Okay.
What you can see Walmart representing the geographic distribution of one local approach, one approach. So here you can see that Asian countries are highly present and are ready to make investment in one of all these. For example, by countries like USA, they market as low, but doesn't mean they are less. This just means they are already major market. So this visualization represents global interest in this domain, but despite this interest, the practical deployment of models our study is to bridge the gap by offering simple and accurate model. So technical greenhouse deployment method is essential for agricultural productivity, yet traditional methods rely on manual monitoring and static systems. These approaches are often labor intensive, efficient, and prone to error. So, and are such that precise temperature prediction is critical because it directly affects both crop yield and energy use. Despite the rise of machine learning in greenhouse agriculture, many proposed models are readily deployed due to complexity, high computational volume for generation conditions. So our research addresses these barriers. So the goal of our study is visual, because we looked at six different models in open access datasets. And we identify key environmental features that most strongly affect temperature, and then we looked at our model and compared its findings from the related literature. So what we found from literature review is that LSTM models, different models perform better for large datasets, and by contrast, what they often repeat when the data is limited, and then by contrast, ensemble models like random forest and gradient boosting show high accuracy and efficient predictability. What we also find out that many existing models either use private datasets or involve only one algorithm. Our contribution is to compare 6 ML models under the same conditions, using the same dataset, metrics, and parity. So here we use Kaggle greenhouse center data consisting of more than 17,000 samples for every 10 minutes between March and May of 2021. So data processing included handling missing values, for analysis, and standardizing timestamps. For deep learning models, we also apply restocking and dropout to reduce overtaking. Like this. So here are the 6 models we tested. So multi-linear regression, random forest regression, GBoost, supervector regression, KNN, and LSTM. So we use standard performance methods, we have zero and R-squared score. And for deep learning models, we monitor training and validation work. Overfitting. Next slide, please. So results we got is that random forest shows the best performance with an absolute error of 1.43 in the section and an R-score of value of 0.96. The random forest score at the second model and multi-linear regression show moderate result, ANN underperformed, while LSTM show overfitting. So here you can see this for action and in the next step, we further compare our results with existing approaches. So our results show competitive performance against existing studies like LSTM, ANN. It's also of performance CNN, LSTM model proposed in the teacher review. Also, some models show slightly higher results. Our performance model is still within comparable range. So it's good promising, and with further investigation and optimization, it can provide even better results. So here we did teacher importance analysis. So you can see the greenhouse humidity and then CO2. And two top predictors. Just one clarification. Yeah, this teacher importance in the random forest model is ranking versus greenhouse humidity as a top predictor by CO2, which aligns with teacher importance for excellent rather boosting model as well. So we conclusion random forest outperform all other models. LSTM show overfitting. Learning models fail to generalize. So, and in future, we are planning to integrate the real-time center data. So, enhance features engineering, optimizing the learning architectures for better results. So, next slide, please. So, thanks for your attention.
Are you planning to create a module for decision making, or to create some recommendations for the greenhouse? Maybe are you planning to implement some more parameters inside the greenhouse?
So in the future work, we are planning to work with real data collected from greenhouse. So yes, we are also planning
I don't have the question. I have it just for future remarks. Do you know that in the university we have the Agritech Research Center? And I'm a representative, you know. For the future works, if you would like to collect the real-time data, you can use our Growbox. Do you see? So that's why. Very interesting, and we can work together. Yeah, because nowadays we are really collecting the real-time data. So you are also welcome always. Okay, thank you.
Thanks so much. So next, ID number 401, Dinara Imankova.
Hello, yes, I'm here.
So Dinara, can you share your screen presentation?
Yes, I'm sharing it.
Okay.
Do you see my screen?
No.
What about now?
We can open your presentation, okay? And you can start your report.
It says to me that I couldn't share my presentation actually because other member is sharing his screen. Yeah, thank you. Do you see it now? No? Um, um,
Maybe you send you and you will continue after one author, okay?
okay, thank you.
Okay. Please send it here in our chat.
Yeah, okay.
So next, paper number 417. Right, okay?
Yeah, we have a. Maybe you can call the representative if she would like to attend. My partners for the support and the novel approach to emotion using 10,000 motions and the verified technical physics applied machine learning models study evaluate the effectiveness of color-related motion prediction. The main division in this paper is dataset collection for motion classification, theoretical evaluation of machine learning models, and the development of the color-related motion. Compare other studies, I like to highlight things. Main difference our study other research is we collected real data, but real world database in digital art, and we use interpretable ML model. First part our methodology focused how we build our dataset. First we use method parsing from Data and Art platform, and we researched 10 emotion keywords such as love, sad, angry, and in table 1 you can see full list our emotion words and the number of images for each emotion. And after collecting the data, we group our emotions to categories: positive emotions and the negative emotions. And you can see for two. The last figure shows one example of images from the collected data. The next part of methodology is color processing. We developed a simple pipeline to extract color pictures from images. This is a Pseudocode algorithm creates color picture from CSV. We put each names, pass to each color, and the color history. And the figure 5 shows our color history. Our algorithms a new CSV file which color pictures for each image. First, our algorithms read input CSV to get image and for each image field name, build the full path to the image and give the image count number of pixels matching each color tone. This color is and the count number of chromatic pixels. And finally, we give the CSV file with field name, images, and the body color count and the chromatic count. The sample charge our text. Frequency count for each image. The next step is treatment. We split our data set 70% training and 30% testing. After we trained our model, three machine learning models, SVM, decision tree, and the random forest, and we evaluated performance standard performance metrics, accuracy, precision, people, and the F1 score. Right shows classification results of ML models and the confusion methods. As you see, random forest gives the best results, and the confusion matrix shows how our model shows correct and incorrect. Like other studies, we studied some limitations. First, we used only color features. Then we no subjective validation done, and this is important features, important areas from our future work. And in future work, we can include other visual features such as other features including symmetry or texture, and then we want study human validation, and here the human validation result with our research. We showed that it's possible to classify emotion digital art using only color features. Models using again decision tree and the random forest, and especially random forest with some colors are clearly linked to positive or negative emotions, like soft pink for positive and dark red for negative. This research helps not only to classify emotions, but also to understand how color affects the way we feel and perceive.
Can maybe a question? You can.
Yeah, thank you very much. Because it's very interesting and something new, new approach to be happy. I think like that. And therefore, my just one question to you: how this project, your results in future, can help to people? To be much more happy. My first question. And second one, is it possible maybe using your result to increase the quality of the decision making? It doesn't matter in any company, in any maybe it's question just for thinking, but I have the same question. Thank you. Thank you. So JC, just your idea.
Hello, can I ask question?
You can ask
or you can type later, okay?
Yes.
Okay.
How our model work as other areas. And you can approve this and say, I can ask you, way which you wanted to define, because it's very interesting, something in Europe, the way to one of the way to get the good decision making. I think so, doesn't matter what kind of so they have planned to implement maybe to increase the business or for example HR maybe I don't know company for the I don't know students for example. So my question is Okay, just speak, you know, just continue, she forgot. I trained our models for global. Yeah. But I for myself, yeah, the other, okay. Because I gave the result, but I forgot. So it is in the focus.
So we have one more question from our authors. Dina, you can ask a question.
Yes, hello. Thank you for your presentation. I have one question. Why is there no neutral category, only positive and negative ones? Are you hear me?
Yes, yes. I think this is enough.
So next, page ready number 41A, Nargis.
Yes. Okay. It says that I can't share my screen because someone else is sharing.
Yes, we have shared your presentation and you can start.
Like, okay. Okay. Hello everyone, my name is Nargis Marigazdarova and I'm honored to present our collaborative research conducted across several leading universities in Kazakhstan. The title of our work is a comparative study of machine learning and large language models for SQL and NoSQL injection vulnerability detection. This study aims to explore and benchmark modern AI approaches for securing software systems from injection-based attacks. And next slide, please. Injection vulnerabilities remain critical threats to web apps. As data volumes grow, databases are key targets. Major breaches like Yahoo, LinkedIn resulted from SQL injection attacks. With NoSQL's rise, new injection threats evade traditional defenses. We explore how AI, particularly machine learning and large language models, can address this security gap. This study compares machine learning and large language models for detecting SQL and NoSQL injection vulnerabilities in source code. We also fine-tuned GPT-4 Mini and trained machine learning models, evaluating both approaches separately. A key contribution is our open source manually verified NoSQL injection dataset. Results suggest a hybrid approach combining both techniques. Next slide, please. SQL injection attack relational databases by manipulating queries, as you can see here. NoSQL injection target unstructured databases like MongoDB. Their flexible schemas evade traditional detection, making machine learning and large language models crucial for defense. And now, next slide. Let's talk about our data sources for SQL injection. We use three public datasets, filtering for CWE89 vulnerabilities, resulting in more than 500 labeled C++ examples. For NoSQL, no datasets existed, so we manually collected and verified 103 real-world snippets, linking them to public sources for reproducibility. This open source NoSQL dataset is now available in GitHub. Now we move on onto our methodology. For ML detection, we converted code to numerical features using count vectorizer and used random oversampler to randomize our dataset. We trained 7 models, optimizing each of them by grid search CV library. Performance was evaluated using accuracy, F1 score, and array under the curve for robust comparison. We also trained GPT-4-Mini on our datasets to leverage LLM's raw code processing using JSON prompts while monitoring JSON prompts. We fine-tuned the model over 3 epochs and monitored loss of this model. Unlike ML models requiring vectorization, this approach directly used contextual understanding of code syntax. And now in the next slide, you can see the, this is this slide. This is our results for SQL injection detection. And random forest led with 99% of accuracy. And the other models also performed well due to the SQL's structured nature, as you can see in this bar chart. And in the next slide, you can see NoSQL injection detection. And this performance varied more significantly. Logistic regression led with 81% of accuracy, and other models show weak results. These results highlight ML's challenge with NoSQL's flexible syntax and limited dataset size, as shown in the bar chart. And in the next slide, we're comparing large language models and ML models and reveal their case trends. For SQL, the LM scored 95 accuracy, but dominated NoSQL injection detection with 97% of accuracy, outperforming all ML models. This shows LM excels with unstructured code context, where ML struggles, while ML remains strong for pattern-based SQL, as shown in the side-by-side charts. And in the next slide, our study revealed key trade-offs. LLM excel at detecting NoSQL injection by understanding contextual code, but require fine-tuning. ML models are more efficient and effective for SQL injection detection, but struggle with NoSQL's nuances due to vectorization limits. Additionally, while SQL injection datasets are abundant, NoSQL injection datasets remain scarce. In the next slide, our findings reveal complementary strengths. We recommend context-aware hybrid approach, and also we open sourced our NoSQL dataset. Future work includes expanding datasets, adding more multi-language support, and integrating models into security pipelines for real-world protection. So thank you for your attention. I will be happy to answer your questions.
Hello, I have a question. Thank you for presentation. It was excellent. And question is, why did you decide to focus on NoSQL injection attacks?
We explored injection attacks, and injection attacks have several types of attacks, and NoSQL injection is one of their type. And what we found out that current datasets don't focus on this type of attack. So we find this research gap and decided to collect our own dataset to address this problem.
Thank you. Thank you.
Okay, so it's very interesting topic. Also, in my opinion, can be used in every type of sections, from manufacturing to let's say just all household sections. I want to ask how many of the SQL injections have you done? What type of SQL injection did you use?
You mean what type of data we collected?
I mean, so how much SQL injections have you used? I mean, like, how much amount did you try to have?
We collected 103 values. It's code fragments. They can be like in small sizes or in the big sizes. It depends, but it's 103 code fragments. They are vulnerable and non-vulnerable to NoSQL injection attacks.
Okay. And about the type, I want to ask, did you try to apply triggers in the SQL injections, or did you just use the simple query?
No, we didn't use malicious queries because several researchers already addressed this problem about NoSQL malicious queries and SQL malicious queries, but we decided to focus on in the source code itself that could be vulnerable to the NoSQL and SQL injections. Yeah.
Thank you.
Thank you.
So we have one more report for today. Paper ID, it's our first paper ID for today. It's ID number 205, Roman Mazurenko. Roman?
Yeah, greetings again. Yeah, this time I'm gonna be presenting, just a second, sorry. Yeah. So yeah, my name is Roman. I'm from Kyiv National University of Construction and Architecture, and I'm pleased to present our joint research focused on enhancing neural STEM learning through ontology-based analysis and data integration. This work stems from our broader efforts to improve intelligent systems adaptability and semantic understanding in complex environments. Our purpose was to investigate how intelligent user interfaces can become more responsive and adaptive by grounding them in domain-specific ontologies. We explore how concepts familiar to users, when formalized as ontological structures, can enhance semantic interaction, navigation, and iterative query formation. This relevance extends to distributed semantic systems where intelligence is closely linked to how well systems understand user intent in natural terms. Ontologies serve as a critical foundation in AI for structuring domain knowledge, supporting interoperability and enhancing explainability. They contribute directly to improving data markup and guiding the design of neural networks. Ontologies also play a key role in explainable AI, helping models articulate the rationale behind their decisions and enable knowledge transfer across domains. This integration of symbolic and sub-symbolic learning create systems that are both intelligent and semantically aware. Automating ontology creation from natural language is a complex challenge. We face semantic ambiguity, lack of text structure, and insufficient validation resources. Existing ontologies may be outdated or too general. Our goal was to develop a robust methodology that handles these issues, supporting scalable, semantically coherent, and adaptable ontologies that can fuel intelligent training pipelines. In our work, neural networks function as artificial experts within intelligent data environments, or IDEs. These environments generate concepts by formalizing and unifying object representations. A multi-agent approach like PAS supports this by improving reliability. Notably, IDEs are not closed systems. Gödel's theorem highlights the inherent incompleteness of external knowledge, underscoring the importance of internal consistency in knowledge modeling. IDEs face numerous real-world challenges. Tasks that exceed computational limits, contradictory problem formulations, or incomplete knowledge. Many tasks require unacceptable resources or lack verification mechanisms. Our system addresses these by enhancing relevance through globalization, sharing and validating data across environments, and by building adaptive structures that manage inconsistency and ambiguity effectively. The operational analysis of knowledge input involves unifying representations across multiple conceptual layers. This includes changes in concept relevance, dialogue intensity, and semantic graph extensions. We analyze how concepts are introduced based on denotation graphs, semantic networks, and evaluation metrics that reflect the complexity and evolution of domain knowledge. Our core methodology integrates ontological knowledge directly into the neural learning process. Starting from raw text, we extract concepts and relationships to build a structured ontology using semantic parsing and formal logic. This ontology is then encoded in RDF-OL and used to guide the training of our neural stem model, an LSTM variant that benefits from enriched features. What's unique is the feedback loop with the IDEs, a multi-agent framework that tracks relevance, updates concepts, and adapts the model in real time. We use metaphorical meta-heuristics like evolutionary algorithms inspired by biological systems to optimize the learning and ensure adaptability. The result is a system that not only learns but evolves semantically with its environment. To conclude, we developed a methodology for modeling the correlation between cognitive and semantic processes in concept formation. This involves identifying similar objects, forming equivalence classes, and generating new concepts based on semantic prototypes. We also introduced metaphorical optimization techniques to enhance system adaptability. Ultimately, combining ontological modeling with cognitive semantic strategies paves the way for intelligent systems capable of autonomous adaptation and deep semantic reasoning. Thank you for your attention. I will be pleased to answer any of your questions.
Online audience? Maybe I have a question just in general. Can you tell me your future plans with your research?
Yeah, thank you for your question. So actually, there was already interest in this topic from other researchers, some French universities, I believe. And because right now, as you might know, like AI is very popular and it's developing in different directions. So this like development of ontology is very important to understand the reasoning behind the decision that AI makes, and it makes it possible to like move forward, understanding better how you develop your AI models. So yeah, that's and also like this is the topic that has been researched by the main author Olena Gorda for a while now. So she's really an expert here, and yeah, we believe that this like ontology based approach has a lot of potential.
So, dear colleagues, we have one more report. Yes. Dinara.
Okay, thank you.
Thank you very much. Yes.
Now something wrong with
Something
your
happening to me today. So sorry for that. I don't know what's going on. Can I just turn off the camera?
No, sorry, but it's tricky to environment.
Is that okay?
Yeah,
I'm
it's
sorry.
okay, but
Yeah, I'm sorry. Oh, I think it takes lots of time, yeah, to just can you just show my presentation, please?
Have shared it and you can start.
Yeah, thank you for today for having me, and I would like to share some uh, uh, with our topic, which is privacy challenges in environmental IoT systems, a case study on air quality monitoring. Next slide, please. So, as an introduction, I want to say that environmental monitoring also, smart cities becoming more advanced, affordable nowadays, and it's expanded all the possibilities of data collection, analysis, and also new technologies. Actually, today, helping to increase that Internet of Things. But these systems often lack of robust privacy mechanisms, and especially in low power wide area networks. So for today, we are exploring the LoRaWAN system. And in the first place, we are put for today this security in our system. Next slide, please. Problem statement of our research. So we actually can explore anything which is included into the smart cities, but actually our the main area is the air quality systems, which is we are using in Almaty, and it plays a key role in environmental monitoring. It is often lack of consistent encryption and the clear policies about data ownership, the consent and the sharing, and it creates the risks of data leaks, unauthorized access, and many more. Next slide. So the objective is to developing the methodological framework for secure data transmission in IoT-based air quality monitoring system. Our task were to find the privacy, like identify key privacy vulnerabilities in existing monitoring system, and we explore lots of monitoring systems. Current cryptographic and architectural solution are explored also. We are proposing the security model, which is combines IS-128 encryption, ACDH, elliptic curve Diffie-Hellman based on key exchange, and the HMAC SHA-256 for authentication. And also we a little bit just explore about the GDPR. Yeah, next slide, please. We did, as I said before, some searching of the works, and we identified the key limitations of that works. And it's not only included air quality systems, but also water pollution, forest fires, electricity meters, and so on in the related works. In the next slide, we built the air quality monitoring system, which is distributed some sensors, which is sensing some pollutants, for example, PM2.5, PM, particulate matter, PM10, CO2, SO2, NOx, and the temperature, humidity. Also, it includes the GPS, some time models, and transmitting it securely, in our case, via LoRaWAN. So here we are exploring secure communication, how to transmit that data, which we are just keeping from that sensors to our database. Next slide. So this is technical approach, and I'm here just showing you the general architecture of the system, which uses LoRaWAN technology for the long distance, low energy data transmission, and it's ideal for energy efficiency wireless network. Key benefits are here, including scalability, stable connections, and it operates in 868 megahertz unlicensed frequency range. And this is, as I said, general architecture. Here we used network server, application server, and also it's published, the data published by MQTT for processing and the visualization. Next slide. Some technical approach that we identified here. So LoRaWAN actually works by using two activation methods. So it's OTAA, which is generates the session key dynamically using the root keys, and ABP, which is pre-assigned session key. So now in our work, we worked with the ABP. So we choose ABP just to get the full control of the key distribution, and the application server key is shared only between end device and the application server, which is ensuring the end-to-end encryption. And we further strengthen the privacy by using elliptic curve Diffie-Hellman to derive that application server key. And the KMAC, it means HMAC 256, to avoiding the key sniffing and spoofing too. In our case, we are just choosing and implementing this type of security because of in many cases it used some external sources like servers as an application server and a network server. But in our case, we are just storing it in our own storage. Yeah? So that's why we need to use it, like transferring data more securely. Next slide, please. Our algorithm consists like 4 steps. In the previous slide, I explained how we are applying here. So just to prevent key sniffing and spoofing here, we are using ACDH, Diffie-Hellman, and for both end devices and the application server, it generates that ECC key pairs and exchanging it, exchange that public key to compute and share the secret. So this secret split it into 2 parts: application server key for the encryption and the key MAC for HMAC based integrity checks. In standard LoRaWAN MIC MIC ensures integrity only in network server. In our case, it should be between end devices and the application server. So that's why we are implementing in this. It is helping us to like detect any tampering, ensuring true end-to-end authenticity and data integrity. Next slide, please. What about some GDPR? So actually, in our case, only the data about our location can be sensitive. In this case, we can just work with it. But in other cases, as you may see from this table, they are not sensitive for. But our proposed security can be used in health monitoring, for example, yeah, or a meter, IoT metering. Next slide, please. So for the evaluation, we just did it. The performance actually only can be done with analytically and also in the OneNote. But we are going to, as a future, our works we will do like for the more nodes to see how it going to be work. So in these slides, you can see that our IS 128 CTR in CTR form and the HMAC increasing linearly with the size of the sharing data, and ECDH just introducing 1 time setup cost, and for 18 byte, as I said, for 1 node packet, it will like IS 128 takes approximately 1,572 microseconds. So next slide, please. So we identified the privacy gaps in existing IoT security models in the LoRaWAN based systems. We are just presenting you a cryptographic framework today. We going through the GDPR principles, and our future work is implementing it in large scale testing. It's ongoing actually. So that's all for today. Thank you for your attention and thank you for seeing me like this. I'm happy to answer to your questions if you have it.
To know why you have chosen for your research, Laura.
Yes, it's.
If you consider another one, why? I mean, what the best maybe side of things which give to you the possibility.
If I hear it very correctly, why I'm using LoRaWAN, right? Because it's very like low level of your voice. Sorry. Why we choose a LoRaWAN connection? It's because we can send the data the longer range, yeah, longer distances, and it's low powered. For example, we are just we built this setup, and then we are just leaving it. Yeah, no changes, nothing. We are not coming every day to check the batteries. We are just seeing it, and then low power, like LoRaWAN, helping us to like set up this low power, yeah, only for this reason, because Wi-Fi, GSM modules are just very like needed more energy from our tiny devices. So that's why. And here, that's why we applied in the long range distance and in unlicensed. So no need to buy any license from our authorities. So that's why we are implementing the LoRaWAN. And we tested the distance, but it's like other topic, and it's really helping us to transmit the data, and we identified that gaps. Thank you.
Yes, I think we finished.
Participated offline and online. Now we have finished our second day of IEEE CIS conference, and I think we have also the few papers that was missed today, and we are trying to fix and trying to give them opportunity to present their works tomorrow. So thank you for everyone, and hope to see you tomorrow. And that's all. Thank you.
Thank you.